So in this video we'll be talking about a common application of global variables within myCNC, which is the usage of our hardware inputs and outputs states. So a hardware output or input can be either on or off, 1 or 0, and we utilize this by using global variables, which are our global variables 7180 through to 7187. So the first four are storing the inputs, and the last four are storing the output states. And these are stored in 32-bit increments. So for example, for 7180, this stores your input pins 0 to 31, this stores 32 to 63, etc., etc. Similarly, 7184, which is your outputs, stores 0 to 31, so outputs 0 to 31, etc., etc. So now let's go back to myCNC and see if we can write out some sort of an example to show how to utilize these global variables. And the example that we'll be using is concerning the binary outputs. Let's say we have some sort of a binary output here, let's say binary output 12, that we would like to turn on and off. However, since there's no dedicated toggle within myCNC or a toggle command, there's only an on or off command, or perhaps there's a port set, port clear, if you're aware of that. You have to actually write out some sort of a program to make sure that whenever you are, let's say, pressing a hardware button or you're pressing a hotkey, you can toggle this output on and off. And for that we'll be writing a quick software PLC. So here I'm just going to call this test 001. And I'm going to write out a quick example. So right off the bat, I'm going to be defining a test output 12. So this will be this test output will be equal to 12 within my code. Next, I will be obtaining the state of my hardware outputs using this global variable right here, 7184. So this will be G, or rather, let's say port state 0 is equal to G var get 7184. And next we will be taking a closer look at one particular value within this 32-bit value that we're getting from this variable. We will be saying pin state is equal to port state 0, and this is the AND bitwise operator, which is familiar to those who have been programming in C. 1 left shift test output. Alright, so what does this line mean or represent for us? So we are taking this 32-bit value and we're using the AND operand, which effectively compares your corresponding bits. It takes two operands and checks if the corresponding bits are 1. If either bit is 0, the result is 0, and if not, it's 1. And then we're taking this left shift, so we're left shifting the value of our test output, which is 12. Our left shift is effectively it's exactly what it sounds like. Again, if you are familiar with C programming, this will not be unfamiliar to you. But for those who aren't, let's say you have this value right here, 11100101. you left shift it, and you can see that a 0 has appeared here, and we have truncated, let's say, this leftmost number. Let's say you left shift it once again, you truncate the leftmost number, and you add a 0. Left shift it again, and you're left with 0, 0, 1, 0, 1, 0, 0, 0, and so on and so forth. So you are getting some sort of a value here, and you are comparing it to this port state 0, which gives you either a 0 or a 1 on your pin state. Next, after you get this 1 or 0, it's a very simple if-else command. So if your pin state is equal to 0, so if our output is off, oops, there we go. If our output is off, we will port set it. We will port set this test output. And if it isn't, we will port clear it. So there we go. All right, so now we have created some sort of an if-else logic here. So this is the end of the program. And let's say that we want to very quickly illustrate how this works. I can, as a matter of exercise, again, this is not something you have to do, I can add some sort of a timer. So let's say timer is equal to 20. Do timer while timer is more than 0, and we will be running this in a do while loop. So this will be do while so this will be continuously running through this loop within it. It will constantly check your port state, then it will check the pin state, and if the pin state is 0, it will set it to 1. If it's not, it will set it to 0, and then it will wait for our specified time, and the loop will start all over again. So let's see if I have written this out without any mistakes. Alright, no, that's all good. Okay, now we should expect to go back and to see this to turn on and off regularly. And there it is. Every few seconds we see this blink because the program checks the port state, and then it checks the pin state, and then it simply toggles it within your application. So this is a very simple sort of a PLC which involves these global variables. However, this should be a good starting point for you to get familiar with them and to use them in your own PLCs later on. Thank you for watching. If you have any more questions or if you require any more information, feel free to visit our documentation at docs.pvautomation.com.